So welcome everybody. If you're not familiar with the webinars, we do these every 2 weeks. And at these webinars, it gives the staff at SHARCNET to get in contact with the users and talk about specific topics that are useful for researchers using high-performance computing, either within SHARCNET or sometimes more generally. Now, one of the topics that's becoming important to us at this point is the research computing resource renewals that are going to be happening during the 2017 year. So what I'll be talking about today mostly is what we can sort of forecast in terms of the new systems arriving, and specifically focus on what that means for SHARCNET users in terms of transitioning from whatever SHARCNET system you're currently using onto the resources that are going to become available with this resource renewal. Again, my name is James Desjardins, and I'm a technical advisor at SHARCNET. We also have John Morton, who's a technical manager for SHARCNET, who's agreed to be here part of the discussion later. So we'll be recording the presentation, but feel free to talk during the presentation later, as that won't be posted at YouTube. So as an overview, I'll just give you a description of what we're going to talk about. While moving over to the new systems, it's important to keep documentation up to date. And what I'm going to go through initially is the overview of the online documentation, basically where you can go to check for updates about details of resources coming in and how you should handle migrating to them. We'll go in more specifically about the new system details after that. Then we'll talk about the legacy system defunding schedule, so what you can expect of the system that you're currently using as they are scheduled to go offline, being replaced by the new systems. We'll go over some details of the properties comparing the new systems versus the legacy systems. We'll also talk about the new infrastructure for data storage and what you can expect for your files. Another thing is the priority of usage and resource allocations, how that's changing, and what you can expect in terms of throughput as we transition to the new systems. Importantly, we'll also go over the support and communication avenues that are going to be used while these new systems come online, and sort of the landscape of the infrastructure changes. And then finally, I'll talk about the specific differences for SHARCNET usage. Basically, the things that you're familiar with now, and you may be used to transitioning from one system within SHARCNET to another, but there might be some extra complications if you decide to transition from a current SHARCNET cluster to one of the national systems. So some of the things we'll talk about is the actual layout of the storage systems, as well as the new scheduler. Now, all of these things we actually have instances set up, so you can already start testing your submission scripts in the context that will match very closely what's coming up around April. And I'll go over a demonstration of things like just accessing the project space rather than work, using Globus to transfer files, tarring a large number of files before transferring, and also go over a little demonstration of Slurm that has an instance on an existing SHARCNET system that you can already test. So in terms of the online documentation, what we really want to get across is where you can go at any time to get up-to-date information about the systems moving forward and what resources you have access to, either if you're getting information or optimizations for transferring files or profiling code, let's say. So in partnership with our partners at Compute Canada, there's also documentation on their web page. Specifically, if you go to Compute Canada, the migration page, you can find an overview of the sorts of information that you'll need, including frequently asked questions, and then schedules for deployment of new systems, information about the system defunding. Now, through these pages, you also get access to wiki documentation that has all kinds of specific details about tasks that you might have to accomplish during the migration. Now, these slides will be shared along with the video, and all of these links will be available in it. So at a later date, if you ever want to go back through this to find where all this documentation is, just feel free to get these slides and use these links. The Compute Canada migration, and migration is really just anything that's involved in helping users on current regional systems move onto the new resources, the new national systems. So the Compute Canada Migration Wiki provides an overview of specific things, the deallocation schedule, details of the new systems, history of announcements sent out to users through the national comms, recommendation migration to new systems, and then specific cases such as some file systems that require migration by staff. We'll get some details about the actual new systems that are planned to arrive come around April of 2017. In particular, for SHARCNET users, we want to talk about in this webinar are the general purpose systems. So these are the systems that match largely the sort of use that SHARCNET users currently have, say on Orca, but really across most of our systems. There are two new national systems. They used to be called General Purpose 2 and General Purpose 3, now called Cedar and Graham. You can find documentation that will be up to date on these systems in this link through the Compute Canada Wiki. We'll go over the details of these systems a bit more later, but always know that this will be the page where the information will be kept up to date on the properties of these systems. So the other thing about getting, the other main thing about the migration is that although new systems will be coming online, the legacy systems will be scheduled for defunding or not being allocated during resource allocation, and then eventually being turned off. Now the defunding schedule is listed here, and there will be more details posted via this site as more information comes in about what the specific details of machines being turned off or limited access will be implemented. Now, beyond the computation resources that are coming online and available and have different properties, there's also the storage infrastructure. To get information about the National Data Cyberinfrastructure, we have this link here. In this, it talks about basically the storage that is not system specific or local to the compute systems. In this case, there's Project, which is similarly the equivalent to the current workspace at SHARCNET. And then a nearline space, which is sort of large scale, maybe slightly longer term storage, similar to what we currently have at SHARCNET, used as freezer. All of this, though, is expected to be active data usage. In terms of beyond the actual properties of the infrastructure that's coming online, documented in the links that we just went through, there's also just general directives of sort of what tasks you might have to be aware of that you should be performing or that will be performed by staff on your behalf. So in the general directives for data migration, there are instructions on basically what to do before migration starts. If you find out that one of your storage systems is going to be offline, whether it's the staff that will be handling the data movement or whether it will be your responsibility to do this, We go through several instructions like cleaning up and archiving and compressing data, avoiding duplication. But there are specific instructions here for how to handle that. At this point, in terms of SHARCNET users, there isn't really any pressing issues in this way. Still, at the end of this presentation, we'll go through some basic procedures or best practices for migrating the data if you'd have to move across systems. The next topics are really about sort of priorities in the queues and the resource allocation procedures. So you can find documentation for this. Of course, the resource allocation applications for this year have already gone through, but you can find details about the properties of these allocations. This really defines all users' priorities in the queue, and basically the likelihood of your jobs getting in if you don't have an allocation, and the sort of the percentage of the total resources available on these systems. For example, allocating 80% of the systems allows the 20% left over for all users, and then we have estimates of how many core years you can expect without getting an allocation. Another recent difference, and has been in effect, is there are different types of allocations. For example, there's what used to just be called the resource allocation competition is separated into the RRG, or the research groups, resources for research groups, or the RPP, so the portals and platforms. And beyond the resource allocations, we have documentation for the Rapid Access Service, or RAS, which used to be called something like the default usage or opportunistic use. In the RAS documentation, this is where you can find out what is expected if you don't have any form of resource allocation awarded. And we can go over more details of this after, but basically what we end up with is a certain amount of data storage you can expect to have on these systems without making a request for it, and you can expect a certain number of core years. At this point, it's set to be about 50 core years. Anything below that, you aren't expected to apply for a resource allocation. But the other important thing to know about the rapid access to compute is that these cannot be guaranteed in any way. It's highly dependent on the number of users and the type of usage that's happening on the systems. And finally, after all of the topics and documentation on usage, there's also the Globus documentation. In the Globus documentation, you can find full access to using the Globus file transfer interface. And in documentation like this, centrally at the Compute Canada wiki, you'll also find links to the regional details for how you would access specific details for your clusters. For example, going to the SHARCNET Globus documentation will give you the layout of where you would find your data on a certain scratch system, for example, to be able to transfer it using the Globus system. So moving past the documentation, what we can do is just start taking a look at what we know now about the new systems. Now, the new systems are on track to being available sometime either April or soon after. And one of the systems is going to Waterloo. This is the General Purpose 3 system, now known as Graham. And on this link, you can find the specific details of basically its file systems, what's available in home and Scratch, and then the project system, which is provided through the National Data Cyberinfrastructure. You can find more details about its interconnect, and most of what we'll be talking about today is just in terms of the number of nodes and cores, as well as the amount of memory. Now, In terms of SHARCNET users, important thing to note is that there aren't properties in existing SHARCNET systems that don't exist in the new systems that are coming online with the general purpose system. And we'll talk about some of the details of the changes between the configurations that relate to the type of use that's typical at SHARCNET. Now, if we just look at it in terms of nodes, there are base nodes, large nodes, big memory nodes, and big memory with 3 terabytes of memory nodes, as well as some GPU nodes. Now, the base nodes, we have 800, and there are 32 cores per node, total of 25,000 cores. Each of these nodes has access to 128 gigs of memory, which works out to 4 gigs per core with over 25,000 cores. Now, as we move down here, we see that these nodes basically have the same configuration for the most part here, and then increase in terms of the memory that's available to them. So the large memories have 25 or 256 gigs of memory, and then 512. Then the largest memory have access to 3 terabytes and have 64 cores per node. And then back down to the GPU nodes that have 128. So what we know now in terms of the design of what's going to hit the ground at Waterloo is going to be over 33,000 cores and 320 GPUs, and importantly, piles of memory that will go into producing more throughput. So that's the one general purpose system that is scheduled to be in place sometime in April 2017. And then there's a second general purpose system that's going to Simon Fraser University. These two systems are set to be very similar with some differences, but are both in the general purpose usage that's typical to the current SHARCNET infrastructure. Set up the same way with base nodes, large, and then the big memory nodes on 3 different levels, as well as a couple cases of GPUs, including sort of a larger memory GPU set. So both the GP systems are relatively heterogeneous in the way they're set up, mostly in terms of the amount of memory that they have access to. At the end of the day, Cedar is similar in that it has over 27,000 cores, has more GPUs, and plenty of memory, more than GP3 or Graham. So those are the new systems that are coming online, and in terms of SHARCNET use, all of the current use cases that we can think of are covered by these systems. In terms of numbers, what we really want to see is of the systems that will be leaving as the new systems are phased in, what sort of, just in terms of the simple aspects of core counts, can we expect? And ideally the case is that there's never a decrease in research throughput, but what we're doing is always increasing the amount of capacity that's available to Canadian researchers. So on the documentation page, if we just go through a quick overview in terms of the number of cores that are set to be defunded. The defunding is really what we'll say is, after April of 2017, these are no longer considered for allocating resources, and the amount of time that is actually available will be in terms of discussions for making sure that throughput stays as high as possible. So of the systems that are currently marked as being defunded at the end of March in 2017, basically at SHARCNET we have about 10,000 cores. And then the ones that continue to be allocated during this year are Orca and Monk, and then they make up over 9,000 cores themselves. Now, the next aspect is, with the coming of the new national systems, is that, wherever possible, in association with the Compute Canada partner, there's an attempt to sort of unify resources where it's likely that this will increase researcher throughput. So what this means is that there will be fewer systems, very large systems, but these will have more users from across the regions. So if we sort of put together, just in terms of number of defunded cores across all of the regional organizations, what we see is in the 2017 trajectory of defunded cores, there's about 68,000 that are marked as being defunded during this year. Now, just with the 2 general purpose systems that will be coming online during that time, there are over 60,000 cores, and that is still not including 2 other systems that have a more specific purpose. Those are Arvidas, which was called the General Purpose 1, but is focused on cloud resources. And then there's also the large parallel system, Niagara, that's set to come online later in the year 2017. Now, what this allows us to do is, while more and more users from various regions will be using these national systems, this will give us a chance to sort of branch out specialization, where cloud users will have access to specialized equipment, and then the large parallel systems will be able to accommodate the 1,000 plus way jobs that some specialty users will require. So what are some of the topics whenever we're considering this migration of users, and in particular for the type of use that SHARCNET users are using? So at the end of the day, in terms of number of cores that are going to be on the other side of this renewal, there is a larger number of cores that will be available. Importantly, there will also be substantially more memory available to these cores. One of the issues that we find typically in SHARCNET queues is that we'll see on certain systems a lot of cores being idle. A lot of this time is actually, a lot of this idle time, which contributes to decreasing the throughput and larger queue times, is that there just isn't enough memory available to keep all of the cores running. Whereas there are cores that are sitting there that could be working on something, there isn't enough memory that's available to those to keep very high throughput on the systems. So by adding memory, we're actually adding the total number of running cores at any given time. The other thing is that in total, it looks like there's going to be more access to GPUs. Probably as we transition into the new systems, it's likely that we'll have a specific focus getting staff to identify when users could benefit from transitioning to GPUs, and there will be more workshops and actually contact of users who might be able to benefit. Being able to make this transition could also lead to more throughput at the other side of this renewal. The other thing is, we can estimate core years based on the the number of cores that we have, but the actual throughput of each core it might increase because of the new technology. Now, we don't know exactly what each user will experience in terms of speed change given the new technology, and this is something that we'll be working on very closely with the users. As new systems come online, we'll try to provide test environments where users can profile their code and see if there's ways of optimizing it. We hope that just by default, these cores will perform quicker, but it's always the case where there could actually be instances where code will perform slower on new cores if they aren't vectorized, for example. So in this way, as we transition to new systems, there will be initiatives to make sure that users' codes are running as best as possible, and that we do always find a speed up in terms of the new technology. And then, of course, trying to consider, whenever we're looking at the resources that are available in the new systems, that it isn't just about supplying what SHARCNET users have or will demand soon in the future, but actually providing the resources for more users on these systems across the regions. Also, by building these two very large general purpose systems, and then on top of that providing the cloud specialization of large parallel specialization, the general purpose machines will be able to deal very well with the general purpose usage by for example, not trying to run massively parallel jobs on those systems, and those will be able to move over to Niagara, housed in Toronto. So in terms of data storage, as far as SHARCNET users are concerned, we won't notice much difference. There is no need in the near future to be transferring your files. Of course, if it does come up, we'll provide plenty of information through system notices and probably have specific webinars on this. What you'll find local to the systems is the typical thing that you're already used to: a home file system, a scratch, and as well as a temp space that's known local. On top of that are the similar systems in the national data cyberinfrastructure that SHARCNET users are used to in terms of the global access file systems. So currently our work system will match very closely the project file system. In fact, already, if you log into a SHARCNET system, you can go to /project, your username, and that will bring you to your work folder. So the link has already been put in place so that you can start changing your user scripts and interacting with the way that it will be under the new systems. The other one is the nearline. So this is for longer storage, generally slower performance on the nearline. Typical of what you see in Freezer. I think it may, at the same time, not be available to compute nodes. So there are many users using these systems, and this is the sort of thing that we're already used to. There aren't that many changes in terms of how priority will work, as far as we can tell. There's still the resource allocations. You can follow these links to go to the pages. So there's the resources for research groups. This is typically what we have known as the resource allocation competition, the RAC, that we're used to. So basically, this is for any groups that require compute or storage that's greater than the RAS, the rapid access service that's available by default. And these are awarded based on the quality of the science and the highly qualified personnel, both in terms of existing in the team and the intention on training users. Research portals and platforms is the other allocation. Of course, targeted for research portals and platforms, typically not a use that we've been providing at SHARCNET. These are awarded for a maximum of 3 years. So the rapid access service, we looked at the documentation earlier, was defined before as default usage. If you just get your SHARCNET account, these are the resources that you can just start using right away. Now, these resources are available to all users, but the quantities are not guaranteed in any way. It's set to be around 50 core years. And the sort of storage is available in home. It's currently set to 50 gigabytes per user. In Scratch, it's set to 20 terabytes per user and 100 terabytes per group. Another thing that will be explored in the rapid access service is a compute burst pilot. This will be a resource where, let's say, you don't have an allocation, but you have a deadline coming up. there's going to be an experiment with being able to increase your priority so that you can reach a deadline under the rapid access service. And that's something that will be documented as we move forward. So importantly, beyond keeping up to speed with the documentation that's available online and being part of the system mailing lists and keeping on track of what's happening with the systems at SHARCNET, it's important to note that there are communication avenues that are being provided both by the regions that you're currently working in and by the partners in the National Compute Canada. So migration support, we'll start off here, really relates to any information that you would need in terms of, if there's a task that you need to accomplish in order to move from your current regional work onto the new national system. So Compute Canada has a working group together. I'm on that working group, and we have people monitoring ticketing systems for this. If you post some kind of question to any of the resources for getting support from either SHARCNET or Compute Canada, I'll likely be the one who will get it and will help you work through the issue. So in terms of migration, you'll still be working with your regional staff in terms of solving issues that you have, both in learning the new systems or in migrating data. And that's done in collaboration with the Compute Canada migration team. If you're working with allocations, that's really handled specifically by the RAC administration, but also if you have an allocation, you'll be assigned a technical staff and you'll be working closely with that person. The RAC administration will always send out letters describing specifically where the work will be done and what the properties of that allocation are. So in the terms of communicating about how to navigate into the new systems, if you have an allocation, that will be sort of tailored communication to your project. If you're dealing with specific systems in migration and support, this largely is still going to be the exact same avenue that you're currently using with SHARCNET support. So if you're using a certain system and you want to know how using that system is going to change moving forward, you would just do a ticket as normal, or contact your local SHARCNET staff or email, that sort of thing. In general, migration communication is handled by multiple avenues. If there are updates about the new national systems, that will likely come from the sort of national communications or on the Compute Canada website. But the updates of the regional systems, for example, information about the nature of the defunding of certain systems, those will all continue to be coming from and the responsibility of the regions in terms of what the users know about how those systems are operating and are expected to be operating in the near future. So in general, the avenues for communication, we have the Compute Canada portal. There's a national ticketing system. For example, if you email support at computecanada.ca, this will go to a national ticketing system and be entered as a migration issue. I'll likely end up with that ticket if I'm available, and we'll start working through that problem. There's all the documentation also on the Compute Canada wiki. And newsletters and different town hall events will continue to happen, and you should be getting notices for all of those. If you notice that you aren't getting these notices, look into it and contact us. In terms of the continued regional support, we still have the portal, which is the main source of information for SHARCNET users. The ticketing system is where you go to continue dealing with issues. There's our wiki. We have constant events. There will be more events like this one every couple of weeks. And then there are the mailing lists. So if you haven't been in the practice of monitoring the mailing lists for specific systems or even software packages, I would go into your accounts now at SHARCNET and make sure that you're getting notices for systems, because this will become important as we transition into the new infrastructure. So let's just go into a few of the actual differences that SHARCNET users will experience. So SHARCNET has several systems currently, and it's typical for SHARCNET users to move from one system to another, or for, let's say, a new contributed system to come online and an older system to go offline. We have all of the communication structures in place to be handling that, and we've been doing that for a long time. And I believe that SHARCNET users are used to this sort of navigation going from one system to another. What I want to talk about in this portion is really just the differences beyond just moving from one SHARCNET system to another SHARCNET system. What extra changes will come into effect if you move to one of these national systems? So, again, in terms of file transfers, at this point there's no sort of pressing need to move your files anywhere out of SHARCNET system. But whenever those transitions do happen in the future, we provide the Globus endpoints for SHARCNET systems. And I'll go over a demonstration of this and just go over some details about sort of optimizing those transfers in case there are large sets of files that have to move. One of the sort of initial changes that you'll have to work into with your current scripts is just the difference between your current workspace and the project space. But in general, those will have the same property. And again, that link to project has already been made, so you can change your scripts already if you're using the work file system in your jobs. The next thing, so some of the recent information that has been confirmed is that most of the SHARCNET systems currently use Torque along with the SQ sub wrapper to schedule jobs, and this is the sort of thing that we teach. On the new systems, we'll be using a different scheduler called Slurm. Now, the Slurm scheduler is already available on one of the SHARCNET systems, and users can log in there and test submission scripts to see how they'll work on the new systems. And I'll go over an example of this in a few minutes. And I might as well just actually migrate now over to a demonstration. I'll get started with a demonstration of Globus. Now, transferring files from one SHARCNET system to another is typically done just through the terminal using SCP or rsync or any of those resources. If you have to transfer beyond the system and just want to have access to an intuitive interface for doing this in a very robust, fast, and secure way, there's a Globus instance that's available. So if you go to globus.computecanada.ca, you'll brought to this interface. Let me just try to get the right size here. So what you do is you log in. In this case, you'll be logging in to Compute Canada, and you use your Compute Canada credentials here. So I'm James Desjardins, and then let's see if I can get my password right. So logging with your Compute Canada, you end up in this interface where you can transfer files from one point to another. Now, what you end up doing is picking endpoints. So several of the file systems under Compute Canada have endpoints which you can access here. You can also add your own local machines as endpoints to upload data from your site onto one of the Compute Canada places. So what I'm going to do is I'm actually going to select a current SHARCNET endpoint. So this is called Compute Canada #SHARCNET-DTN1. So this is the DTN data transfer node that's optimized for doing transfers. It's ideal for using, even if you're using SCP or any of those things. And what we can do on here is we can set the path to access any of our file systems. So what I'm going to do here is I'm just going to go into my work directory, so work J Desjardins, and I'm doing a little, this is just a little demonstration folder. So let's say I want to actually transfer this stuff from my work, and just as an example, I want to put it into a Scratch system. So the Scratch folders are local to compute systems. So unlike work or home or freezer that are global access, which you can see from all of the SHARCNET systems, the Scratch systems are specific to the compute systems. But through the data transfer node, you can see many of the Scratch folders. For example, this is the path to the Scratch base on Orca. And if I hit OK here, I can see that there are these files in here. So all that you have to do is, once you set the two endpoints, you select a file. So what I want to do is move this one and overwrite the file that I currently have over there. Transfer, and there we go. So that folder will transfer, and then what we can do is we can check for the progress of different systems. Now, one of the things to watch out for is that the transfers of a certain amount of storage differs greatly based on the number of files that it contains. So transferring a terabyte that contains one file is very different from transferring 1 terabyte that has 10 million files. Now, what we suggest is that you encapsulate, if you have a large number of files that needs to be transferred, that you should encapsulate that using tar, for example. I don't necessarily need to go over an example of this, but once you've transferred files under activity in the Globus portal, you can see a history of transfers that you've done. For example, this is one that I was testing yesterday, where I moved the folder that had almost 1,000 files in it and had an effective speed of, let's say, 2.4 megabytes per second. So back to the task list, I then tarred that file, moved a single file, in about 14 megabytes per second. So these sort of transfer rates end up being substantial differences between moving large number of files and then encapsulating them. So another example that I'll go over just before we finish is how we can now log into an existing system to start testing submission scripts, moving from the current typical MOAB scheduler at SHARCNET into Slurm. So what I'm just going to do is I'm going to log into Mosaic. Okay. And if I just list the modules, you'll see that Slurm is the schedule that's available right here. So what I'm going to do now is I'm actually going to go to my project space, which is just linked to work. And I'll go into this demo. And then I'll list the files that I have in here. So what I'm going to go over now is really just the difference between what we typically present in our new user seminar. In the new user seminar, we usually go over an example of logging into a system, creating small programs, compiling them, and then running them. So for example, if I were to run SHARCNET Hello World, it just tells me Hello World. And then what we go on to do in the new user seminar is show how to submit that using the SQ-sub command that accesses the typical SHARCNET schedulers. But what I'm going to do here is just show the difference. Rather than using SQ-sub to submit these, what we do is we can just log into Mosaic here that has Slurm, and then we can create these little job scripts. So for example, if I just want to run my SHARCNET, my SNHW Hello World program, I would create this little serial job script. Now these scripts just set some parameters for the sbatch command. The sbatch is basically now your submission command. set some properties of it, and then in this case just ask it to execute the input to that function. So first of all, if you want to know more about it, of course you can just do man sbatch, and you get all of the inputs that are similar to the ones you're familiar with from SQ sub in terms of specifying the number of cores, the amount of memory that's being allocated, dependencies if you want current job to wait into the queue until the termination of the previous one, for example. So, let's see here. So, if I want to run a job, I'm just bringing up an example here. So what we see up here is basically the script for the serial job. And what this does is sets a couple parameters, and basically a default time, the number of tasks is 1, the default memory is 1 gig, and it defaults to an output file. In order to run a job, the job that I want to run is the executable SNHW. I say I want to perform an SBatch, but I want to overwrite the default output file that I set in my script by the -o, so I want to call this serial test out. I also want to overwrite the default memories that I set in my script, so I can just do it at the command line. Then what I want to do is execute my serial job script, and then this serial job script is expecting an input, and that's going to be the executable that I've defined. If I hit enter, it tells me that job has been submitted, gives the number. I can check current running queues. My job isn't there because it's completed. And then what I can do is I can just check on my my serial test out, and then I see that it just captured exactly like we're used to using SQ7 in the systems. It just captures the standard out of my executable. So basically that's everything that we need to know to change from what we typically describe in the user seminar of executing programs in the scheduler, but now doing it in Slurm on the current system, Mosaic and SHARCNET. And then really from there, we don't have anything else set to talk to. So thanks for your attention. Again, I'm one of the technical consultants at SHARCNET. You can contact me anytime at jdesjardins@sharcnet.ca. If you have migration questions and you submit them either to the SHARCNET ticketing system or the national ticketing system, I'll likely be initially handling it. So emailing help@sharcnet.ca for SHARCNET's ticketing system, or support@computecanada.ca.